Alright, in this video, I'm going to be going over Boolean algebra, which is 1.4.3 in the spec. So, I'm going to have multiple parts of this, but I think this video is just going to go over the basic stuff. So, you'll be learning the fundamentals of Boolean algebra. Also, if you watched the previous video on bitwise manipulation, then this stuff should be pretty straightforward for you. Anyway, let's just get straight into it. So in Boolean logic, we have two basic values, and that's going to be true and false. These values are represented by the numbers 1 and 0 respectively, so 1 is equal to true and 0 represents false. There are four Boolean operations that OCR wants you to know about, and that's going to be not, and, or, and exclusive or. So in my previous video, I already went over kind of how what and, or, and exclusive or do. So if you watch that video, you should have kind of an intuition on what those are. But you might not know what the not operation does. And that's fine because it's actually the most simplest one out of all of these. So each operation can be represented with a symbol called a logic gate. And you'll see what I mean later on. But you're going to actually have to know and memorize how to draw and read each of these symbols. So when talking about the not operation, not has one input and only one output. And I think that's true for all the operations that I'm going to be covering. They all have one output, but not is the only one that has one input. So what this operation actually does is that it just flips the value of an input. So if you have a NOT gate, which looks like this, and let's say you input something into this gate, if it's true, then the NOT gate will just flip the value of it. So true becomes false and false becomes true. And here we have a table to represent all the different outcomes that can happen. So because we can only have one input, there's only two cases. Either your one input is true or your one input is false. And the output is either going to be a false if it's true and a true if it's false. And this is what we call a truth table, which is basically just representing all the outcomes that can happen. You're also going to want to know about the notation here. So they're going to ask you some questions on how you can represent Boolean expressions, and this is what they want you to know about. Now onto the AND gate. The AND gate takes two inputs, well, a minimum of two inputs, and it has one output. The AND operation just returns true if both the inputs are true, and returns false otherwise. So this is what the gate looks like. It kind of looks like a capital D, and the notation is like an upwards arrow. And here's the truth table. So you can see how if, in this case, the inputs are represented with the letters A and B. If both A and B are true, then we have an output of true. Otherwise, it's false for the rest. Now onto the OR operation. So this also takes two inputs and has one output. And this one returns true if at least one of the inputs is true, and returns false only if both of the inputs are false. So this is what the OR gate looks like, and the notation used is like a V, or a downwards arrow, however you want to remember it as. And this is the truth table. So you can see how if at least one of the inputs has a true in it, then the output is going to be true. Otherwise, if both of them are false, then you get a false. Lastly, exclusive OR. This one has two inputs and has one output, and only returns true if both inputs have different values. So the exclusive OR gate looks like the OR gate, but just with a line at the back of it. And the notation is also the same as OR, but you underline the V, or downwards arrow. And this is what the truth table looks like. So you can see how it's kind of similar to OR, but in the first row, because both of our inputs are true, it outputs a false, because it only outputs true if both of the values are different. So let's just get straight into some questions. They tell us a cinema offers discounted tickets but only under one of the following conditions. Either a customer is under 18 and has a student card, or a customer is over 60 and has an ID which proves this. So if we look at our variables that they gave us, A is whether a customer is under 18, B is if the customer has a student card, C is if the customer is over 60, D is the ID, and Q is whether or not the discount ticket is issued. So they want us to complete the Boolean expression below, and they give us that Q is equivalent to a Boolean. They want us to complete the Boolean expression. So basically Q is equivalent to a Boolean expression, and we need to basically form that expression. The three lines here just means equivalent, so I mean, you can basically think of it as an equal sign. So to do this question, well, it tells us here that it only needs to be under one of the following conditions. So either this needs to be true or this needs to be true. And if you remember what the or expression looks like, it looks kind of like this, so like a V. But within these two conditions, each of these conditions have their own conditions, so they're kind of like sub-conditions. For the first one, the customer needs to be under 18 and they need to have a student card. So if we convert that into a Boolean expression, that'll be they need to be A and they need to be B. So if you remember what and, the notation for and was, that was going to be like this, so like an upwards arrow. So the first one here is going to be A and B. That's what it's going to look like. And the second one here, they need to be over 60 and they need to have an ID. So that's going to be C and D. But only one of these needs to be true. So to complete the Boolean expression, I like to separate it with some brackets. I show that either A and B needs to be true, or C and D needs to be true. And that'll just give you 3 marks. Part B of the question basically just gives us even more variables, but basically the same thing here. And they want us to complete a truth table. So we just need to show all the different possible outputs that can happen, given all the possible inputs. So let's focus on this column first. With this one, we're focusing on E and F, so the first 2 columns. And the expression here is going to be the AND expression. So both of them need to be true for an output of 1. So in this case, E and F both are true, so there's going to be a 1. This is the same thing here, there's going to be a 1. And the rest is just going to be 0, because there's not going to be any more ones where both of them are true. Now in this one, we're focusing on E and G this time, but it's the same operation being applied on it. So with this one, E and G, that's going to be 1. These are not the same, so that's going to be a 0. This one is the same, so a 1, and then the rest are just going to be zeros. With this one, we're focusing on these two, so the ones that we just worked out, and we want to apply the OR operation on it. So if either of these 2 columns have a 1 on them, then we have an output of 1. So in this one, yeah, there's a 1. This one is also going to be a 1, and then the rest of zeros, so we just complete the table from there. So here's our last question, and they can also give you a logic circuit diagram, and they want you to interpret it and, I guess, complete a truth table with that information. So this symbol is actually the symbol for AND, and this is the symbol for exclusive OR. So let's complete this column first. So D is the output for AND. So we just need to focus on A and B because those are the inputs that are going into the AND gate. So if we just think about the rule for AND, both of the inputs need to be true for an output of true. In this case, that's not the case, so this is going to be a 0, this will be a 0, 0, 0, 0, 0, and then 1, 1. For x, we're going to apply the exclusive OR operation on D and on C, because those are the inputs that are going into the logic gate. So we look at these two columns. So if both of the values are different, then we can have an output of 1. So in this case, they're the same. This is going to be a 0. This will be a 1, a 0, a 1, 0, 1, 1, and 0.